5,000 people.
Attention, everyone.
But it sounded cool. It is cool.
Used to such a big crowd.
That's right, yeah. Very good turnout. Thanks everybody for coming along. A lot of new faces. Very pleased to see you here. We've got a great talk today. Bryan Tuffnell has been around for a very long time. He was here at the birth of paragliding in Canterbury.
Oh,
He's been a hang glider pilot, powered hang glider pilot and paraglider pilot. And did you study physics? Is that right?
Not physics, no.
No. But he's a very avid Met person, and I've flown with him, and he definitely knows a lot about what's going on. So I've asked him to come along and talk to us about. It's basically a talk, hopefully, about his approach to assessing the weather. He's got a lot of slides, so if you can kind of let him get through it, and we'll maybe have questions towards the end. Is that all right, Bryan? Or do you want questions as you go?
Look, I'd say throw questions in as we go.
Okay.
Yeah.
Okay.
Yeah, we should be able to rattle through a lot of the slides pretty fast.
Okay. Well, there you go. Questions as we go. So, thank you very much, Bryan, and the floor's all yours.
Did you want to do the hints for it?
Oh, no, we've got too many slides to get through there.
Okay. There are a lot of people who come out for a free pizza, weren't there? It's also quite encouraging to note that not everyone is 20. When you get to 62, just about everybody looks young.
Thanks.
Right, so what follows is very much my personal view on aerology. Aerology being what's going on in the air. The slide here I really like. Unfortunately, it's been cramped a bit to fit on the page. This is the Waitoto Valley, which drains west from Mount Espongering, Haast Range. The lake there is what's left of the lower Volta Glacier, which is now entirely gone. And as we can see, we've got an eastern facing slope, a wee bit of morning cloud build up on it, really common for the west coast. Coasties call it Nerg. This talk, always trust Top Gun to come up with some sort of pithy little quote. There are a lot of people here who are far better paraglider pilots than me and far more experienced. I do feel a bit like the student that's talking to the teachers here tonight. Bear with me. What follows is very much just how I look at things. Everyone here can have their own approach. My way is not the way. It's just what I've come up with. It's not perfect. I make mistakes. I get things wrong. I get lucky. So my approach is definitely based on my history. Who's seen this movie Off the Edge? Who's loved this movie Off the Edge? Yeah, okay. I first saw it in 1978. I was a keen young alpine climber, 16 years old, doing my second season at Mount Cook. We were stuck in the village in bad weather, and a group of us managed to get hold of an early copy of this film, trekked to a grotty downstairs room in what's the park headquarters building, put the movie on, the room went blue, and I was incredibly impressed. For those who haven't seen it, the first 2/3 of the movie is skiing, and then there is a made-up hang gliding sequence. They fly off the minarets in Mount Cook in Seagull Mark III hang gliders, and I think this was shot in 1975, and this was just cutting-edge stuff at the time. I was just gobsmacked by this, and as you do when you're a 16-year-old male who's into alpine climbing, suddenly after watching this, you've got to take up skiing and paragliding. This is the Spencer Valley. Two guys, very inexperienced. This is Blair Trenholm, and it's his 6th flight on a hang glider. Yep. So I still think, seen in the context of when this was done, this is the biggest adventure in free flight that New Zealand has seen, in my opinion. Amazing stuff. I mean, you can imagine, you know, you look at the harness, he's on a hunk of plywood with a strap and a seatbelt across his lap, holding him in. He's launched from over 10,000 feet, 3,000 metres. His 6th flight. Amazing. And of course, when you're 16, you see this. This is it. This is your new sport. So, I've been wondering about whether to include this, and I think I will. When I was 20, I was climbing at Mount Cook, and 3 of us were climbing quite a hard line. Who are the alpine climbers here? Okay, we were climbing a new line on the south face of Mount Cook, and we're climbing solo because it was quite a dangerous line, and one of us didn't get through the day. It was just after I'd turned 20, and I was too young to really appreciate kind of what this meant for me as a person. Obviously it has a bit of an impact. Steve and I, the other guy who was climbing, we decided that what we would do was go back in winter and climb an even harder line. The logic in that escapes me now, but it's what we did. We climbed a line slightly to the left of the line where Tim was killed. And I came away from that thinking, look, I need an approach to the outdoors that's better than this, because I'm going to die young. I'm not going to live very long. I needed to look back at the mistakes we made and find a way to move forward that took better account of, it was just a better way of doing things. And I came up with, look, on the day we got facts wrong, our judgment was wrong, and our technique was wrong. And I've kind of kept that over the years. I've been involved with quite a few outdoor sports, skydiving, base jumping, whitewater kayaking, and for me, I can kind of put most accidents, incidents into one of these categories, and I kind of keep that in mind because basically I just don't want to die young. So we're now probably about 84, 85, and I'm into hang gliding, and it looks nothing like what Blair Trenholm was doing, flying off the minarets. Hang gliding has changed, it's different. The performance of the machines is much better. We're flying considerable distances cross country. That wing flew over 200 miles in the Owens Valley. We're not really flying around the mountains though. I flew hang gliders for just under 30 years, I think, and then went to the dark side. Met the wrong people. Good mate of mine, Doug Anderson, persuaded me to try microlights. I flew microlights for 12 years, I think. And again, it's kind of different. With the engine, yes, you can tuck into the mountains. It's kind of, it lets you do other things. This thing would climb at about 800 metres a minute. It's a two-seater. It has a very reliable engine on it. It cruises at about 130 kilometres an hour, and cross countries are, well, you pull the thing out of the hangar, point it in the direction of where you want to go and go. And it was fun. We had a lot of fun with those. That's a two-seater. I can take a passenger. I can put it back in the back with the week's stuff in. But it wasn't really flying, and the engine takes away a lot. So one morning I just woke up and went, I'm not going to fly this anymore. Anyone recognise where we are?
The Newman Range?
Which what?
The Newman Range?
No.
Is it the one that?
Yes. Yep. Waimak, the right. Yep. Klondike Corner, Beeley, Minga. So yeah, I sort of felt I was moving on from that, and the obvious next thing was, here you go, trendy, modern, fashion-conscious paraglider pilot. With paragliders, I felt I could fly in the mountains. I was coming much, much closer to what I really wanted to do, which was kind of be in the mountains. The alpine climate going flying was much more me than anything else I had done. Because of that, I'm usually, my favourite type of flying, I'm approaching on foot. It's often going to the summit of an alpine peak, trying to fly a little mini cross-country in the area. I'm not interested in big distances. I don't need to go far. I don't need to get super high. But I want to fly in an area that I really like being in. To do that, I've got light kit. I've got my favourite wing to take is a single skin with a string harness. It fits into a bag, yay big. The wing and the harness, it's tiny. And it really opens doors. As an alpinist, the things you can do with that are phenomenal. But if you're thermaling with that, you must be certain of your aerology. I've got a big wing, I've got a mini wing, but the single skin is the nicest to carry. And there is something really attractive about doing the most with the least. So that's me, and the approach I have in aerology is the perfect day for me is there are light thermals, I can climb in them, there are no sharp edges, there are no surprises, I can be on my single skin and feel like I'm not taking an undue risk. Now we'll say more about that later because I think there are traps in that. I'm not sure if it's a good approach, but that's the goal for me. So the point is the aerology for that must be perfect. So I know what I want, and it's probably different from what everyone else wants. And that's cool because we are all individuals. So if we take a hypothetical journey, we'll walk up Mount Bruce, go for a wee hike and fly. We'll use that as a way of thinking about aerology. So, I'm not sure that I'll take the single skin on this one. So going back to what I was saying before about accidents, if we flip this around, the best chance of having a good day is if we're spot on with our facts, we have good judgment, and we apply the right skills. And for me in paragliding, facts is just about entirely getting the aerology right. So the other thing is it's easy to think of aerology as a series of risks that we're trying to mitigate, but it's also a series of opportunities. And as conditions get trickier, they both can go up simultaneously. You take more risks, but you can do more. For the guys that want to do big cross countries, this is what you're in. High risk, high opportunity. I remember having a conversation with Ben Kellett of Queenstown, who most of you are probably familiar with. and he was saying he considers his cross countries 100 times more dangerous than his acro flying. And I thought that was an interesting comment, coming from a guy who looks so incredibly cool in his videos. Oh yeah, just wandering along here, 36,000 feet, and I'm having a good time. He's amazing. So the things that I want to focus on are very few. It's basically air and water. This is probably pretty obvious, and I would think that if I asked everyone in the room, a quiet moment, sit down, spend some time, come up with what aerology consists of for us as paraglider pilots. That's it. Wind, convection, shear and clouds. The one thing that might want a wee bit of discussion around is shear. Is everyone familiar with what I mean by shear, or what shear is?
Can you define it for me, please?
Sure. The word that I think a lot of people would use is turbulence. And this is really, I prefer the word shear because it's more, turbulence happens because of shear. If I have a model of the Taj Mahal made out of plasticine, say, and I've got it sitting in my hand, and I rub my other hand across it, it'll eventually turn into a cylindrical shape. And we would call that in aerology rotor. If it's made of a more crumbly clay, and we did the same thing, we put a model of the Taj Mahal here and we rubbed it, it might break off into little bits. Turbulence happens because we have two surfaces in shear. It might be air running one way, air running the other way, and they kind of trip over each other. Does that make sense? It might be air running over a hill, and particularly if it's a sharp edge, the air kind of trips over that edge and rolls, breaks off, goes downwind. Shear is where turbulence happens. Shear is where rotor is made. It can be air on air. It can be air on hill. It can be air running across the side of the hill. The air closest to the hill is slowed by friction, rolls over, breaks off into little bits as turbulence. It could stay as a rotor and roll along the hill. So another way to think of rotor might be to think of a roller bearing. Does that make sense?
Yeah.
Okay, so for me, shear is turbulence. Air goes bad. Clouds are full of information. They're information rich. And the other two I think are obvious. Convection, if you want to go up, we want air to go up. So when we talk about aerology, I think there are a bunch of different scales. I think for us as paraglider pilots, this is a new term for many people. Okay, synoptic is big scale. We're talking a few thousand square kilometres. It's what you see when you look at a weather map. And while it's big scale, it has a profound influence on what happens at a local scale. At the moment, we've got synoptic weather happening outside, damn it. And it's the weather at the moment, obviously, we've got rain, we've got a front, we've got stuff happening that is big scale. If you looked at a satellite photo, you would see it. That's synoptic scale, and it's important because it influences the boundary layer. Who's with me on the boundary layer? Is this a new term for anyone? Okay, the boundary layer, in essence, is the layer of air that goes from the ground to as far as we could possibly get, whether we wanted to or not, in a hang glider. So top of a thunderstorm, if we goof up, top of a thermal if it's a blue day. We're not interested in anything outside that. The boundary layer affects the synoptic wind. You might have a range of mountains. You have, say, a southerly blowing that hits these mountains. It's slowed by friction. It's diverted round into valleys. It breaks up and makes turbulence on the lee side. It's where the sun makes a difference. I'll go into that a wee bit more. And the microscale is obviously, I'm flying here, you're flying here, I hit turbulence, my wing collapses, yours doesn't. And ultimately that's what we're after, but there's no way of predicting that. If there was, we'd fly straight into thermal cores and we'd never have collapses. Right, the synoptic level, coming back to four horsemen of the apocalypse, or four horsemen of opportunity, whatever you want to call them. The synoptic level situation gives us the main wind flow. So it's southerly, it's northwest. It's a geostrophic northeast. It gives us rain. The boundary layer is where the sun comes up in the morning, it heats the ground warms the air above it, a bit of convection starts, and that air above the ground gets mixed. Sea breezes will not show up on a synoptic level weather chart, but they're very real. Valley breezes likewise. Some cloud types, cumulus, form in the boundary layer. The top of the cumulus is the top of the boundary layer. Other cloud types, cirrus, doesn't. It's way too high. So the synoptic scale really sets the scene, and I'm very, very interested in this. I want to see a weather map before I go. I have a favourite source, which is Windy. Windy has an excellent surface pressure chart. Met Service is good, but Windy has 2 millibar separated isobars. It has a little bit more detail and pressure than you can get from Met Service. Met Service, on the other hand, has some forecaster who's drawn in fronts, which is handy. And satellite images. Putting the two together is really information rich. So at a synoptic level, these are the situations that we tend to fly in. High pressure is made from subsidence. Is this new to most people, I assume? Okay, so high pressure on a surface pressure chart. Obviously the air on the surface is high pressure. That has to come from somewhere, and it comes from large scale air is sinking. It's not sinking fast, but it is over a large area. And the reason for that is there is a lot of convergence happening in the upper atmosphere, say. A lot of air is building up in one spot, it's got to go somewhere, and it goes down. So all this air is very slowly sinking. So as it does, what happens to air if you compress it? What happens to the temperature? Rises. Yep. So what's an inversion?
Temperature increases again. High.
Yep. So high pressures tend to make inversions. If the air is warm above warm ground, the lapse rate is poor. Is everyone with me on lapse rate?
How many degrees Celsius it goes down in 100 meters or whatever?
It varies hugely. You can see that in a tetragram. So it's not consistent. There's no will. In an ideal and inverted comma situation, it would warm at the adiabatic lapse rate, the dry adiabatic lapse rate. So because it's warming, what's happening to the relative humidity?
Reducing. Is it reducing? 'Cause
Sorry, I'm quite hard of hearing.
it's going down.
Correct, yes. So there are fewer clouds. The air is warming, so clouds are tending to dissolve or not form in the first place. So high pressure also tends to produce light winds near the centre of the high. Because there are few clouds, there tends to be a lot of surface heating. So in this situation, there tends to be a reasonable amount of flyable weather. This guide tends to be important. If we've got warm air over warm ground, a poor lapse rate, it means that the sun can heat the ground warms up, gets hotter and hotter and hotter, transfers that heat into the air immediately above it, but that air doesn't want to rise. So more and more heat goes into that thermal bubble before finally it breaks off because the air above it won't support it rising. It's got to get really hot. When it does, you have quite sharp edges to the thermal and shear. So as a rule, all things being equal, this is flyable, it's rougher. Postfrontal. The front's gone through, air's from the south. The front has disturbed the boundary layer quite a bit. The air is well mixed. It'll give a great lapse rate. Because the air is mixed, the inversions are gone. The visibility is really good. Or any haze or moisture that's been trapped under the inversion is blown apart. It's gone. It's distributed. Yep.
What causes that haze?
Moisture, dust, smoke, pollutants. Yeah, it just gets stuck. It can't distribute itself throughout the air. The inversion holds it down. Yeah. So post-frontal, it used to be more common. Climate change is really messing up patterns, but it used to be sort of from about September on, we would get great cross-country flying in New Zealand in post-frontal conditions through to about Christmas, because this is when we would tend to get, it's northwest, 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 bang, round to the south, everything's clear, great, fantastic. If you're flying north, you've got a tailwind, the lapse rate is good, cloud base tends to be high. Bob's your uncle. Yep.
Post-frontal, I don't know what you mean.
Oh, okay, sorry. A front. Who's with me on a front?
So it's got to be a cold front or warm
Cold front, warm.
It's one of those.
It's a cold front, yes.
Right.
After a cold front has come through. Yes. Sorry, I should have... yeah. So these are examples. I might zoom in a wee bit more if I was being specific. But we can see here, big region, high pressure, light winds. Everyone use windy? Anyone use windy? Yeah, okay. So we can see light winds, high pressure, bit of a ridge of high pressure through here. It's a weak ridge through here. If we look on the satellite photo, we can see high pressure, few clouds. We can see that ridge. Over here we've got low pressure in the Tasman. We've got a bit of a trough here. The isobars are tending to go a wee bit further away from the centre here than they are down here. So in that trough of low pressure, we have a front. Ahead of that front, we've got a whole bunch of lifted air. rain, cloud, miserable. Behind it, we've got this post-frontal air where the visibility is good, lapse rate's good, great flying conditions. There's of course out over the Tasman Sea. If probably around this part of Australia, it would be good cross-country conditions. In New Zealand, we can see probably around Otago, there's good flying. Light winds, a weak pressure gradient, the isobars are wide apart. Sun can reach the ground. Looks good. Yeah, other parts, not so lucky. But the point I want to make here is surface pressure has a huge influence on the air that we fly on. And this is something I want to know. Now, talking about the synoptic situation, synoptics and boundary layers, each one of them could be a long trip in themselves. So, really, the message is, this is information rich, this is big picture stuff. And for me, I consider it
Hey Bryan,
important.
on the couple of flights back, what was the third flying condition? I think you did high pressure and random.
Random. Okay, something we used to see more of in New Zealand. We're a mid-latitude country. We used to get it used to be a sort of a high would drift across, a low would drift across, a week later would be another high, another low, and this was a fairly regular pattern. This is going out the window now, and we're getting all sorts of bizarre things. My favourite example, I've seen it 3 times, I've used it well once, is when high here, high here. The 2 highs, a lot of subsiding air, it helps keep the sea breeze down. The air around a high travels, anyone know? Oh, okay. So around here, the high is putting a southwesterly across New Zealand. There's another high here. It's putting a northeasterly across. In the middle is convergence. And my longest, most dramatic flight on a single surface, I just got so lucky. I was on top of Rolleston, the south side, and I managed to fly, for those who know the area, from Rolleston to Carrington, Campbell, Rosamond, Isabel, Davies, Murchison, Harper, across to Lancelot, Guinevere, Rolleston, Carrington, down to Waimak Falls, and getting thermals that are workable on a single skin and being able to hop from one neighbouring mountain to the other and pick up a thermal all the way around was just amazing, just incredible. The single skins do not have performance. But that was a lucky situation.
Was that last September?
Was November 2 years ago, I think. But, you know, you see the situation developing and you go, oh, I'm going to try. And you don't know what's going to happen. And in this particular case, I was just lucky. Really lucky. Okay, so we're back to Mount Bruce. We're going up, we want a light pressure gradient. Anybody with me on that? Anyone with me on that? Isobars are wide apart. The change in pressure over long distances is weak. That means the wind is weak. We don't want much wind if we're flying paragliders in New Zealand or anywhere. Favourable wind direction is good. We want enough convection to hold us up, but we don't want to be scared. We want a manageable amount of shear, turbulence. We really don't want to be scared. Sky's clear enough so that the sun hits the ground, and in the perfect world we'd have a nice series of cumulus clouds lighting the way. Okay, in the boundary layer, this is where all the stuff happens. It's pretty self-explanatory, I guess. The sun is everything in the boundary layer, and on days like today when there is very little sun, it's really the synoptic situation that controls everything.
It's really the synoptics what?
The synoptic situation controls everything
Okay.
because there's no sun. The sun isn't heating the ground. This, I wouldn't pay too much attention to this. I just put this in because it makes the point. Sunrise, this is vertical height here, things start changing, and sunset, they change again. There's a real day and night difference to the boundary layer. This is the key thing. Sun comes out, heats the ground, we get flow starting to happen up valleys, we get thermals happening, valley winds, etc. All of this peaks in the afternoon, soon after when the ground gets its maximum heat from the sun, basically. And then at sunset, everything reverses. So up valley winds become down valley winds, anabatic flows become katabatic flows, thermals collapse, and everything goes quiet.
So you're saying here afternoon, you're saying everything peaks out.
Okay, if we have a day of brilliant blue sunshine, because heat drives everything, the sun provides the heat. The time when the ground is at its hottest is afternoon. Yeah. At noon, the temperature is still going up.
Yeah.
So all things being equal, the hottest part of the day is after the middle of the day rather than at the middle of the day.
All right. So that's when it all happens.
Well, it's as far
Generally, you know.
yeah. As far as we're concerned, because if we want thermals, if we're inland, we are chasing the sun, and on a much smaller scale. In the morning, we obviously want to be facing east. Later in the afternoon, we want to be facing west. Middle of the day, we want to be facing north, or we want to be above slopes that are facing in those directions because that's where they gather the sun. So, provided we're looking for thermals.
Understand.
Who knows how to interpret one of these?
I don't.
Yeah, okay. A subject for another time. This is something that you could spend an evening on. This thing, if you understand this, you understand convection in clouds. It's something I would encourage people to figure out. A tetragram QT. This is one of Dr. Jack's last lip maps, which Ross is grinning. He'll know very, very well. What do you think of this day, Ross? Yeah, okay. These are wind barbs. It says it's northwest at all heights. We've got high cloud. We've got a little bit of surface heating. There's no cloud at all in the lower part of the boundary layer. Yeah, I won't go into it in any more detail because it's too involved for this talk.
I don't understand why they can't actually make that a lot easier to read, because it is quite involved to understand.
Yeah, it's a tool for meteorologists rather than
okay.
something purpose-built for paraglider pilots. But yeah, it's full of things that if you know how to read it, it's a really rich source of information. If you understand that, you understand thermals.
He's got YouTube tutorials on reading them.
Yeah, I will believe that, Tim. I would imagine, I think, is there some paraglider pilot who's doing that?
Kelly Farina.
Right.
Yeah.
Okay, well, for those who are inclined, I would really encourage you to figure out how to read one of these.
If the direction wasn't important, it's a bit stronger one.
Yeah, exactly. Yeah. It's not a day anyone will be going flying. This is a compass rose, and it's northwest of all levels. I don't know how well this shows up. A big black diamond like that, and there's 50 knots. That's 45. This is altitude in feet. So it gives you wind, it gives you environmental lapse rate. This is what you were asking before. If this air was descending, it would be descending at that environmental lapse rate. If the air was perfectly wind, it would descend along a dry 80 day. That's dew point. It's too much to go into for now. But it's so full of information. They're not difficult, but it needs to be explained well. Yep.
I do think there is a PDF linked on the RAF website that explains it, but it's quite technical.
Okay. Yeah, it's something a good teacher could explain it in half the time of a bad teacher. It's not super difficult, but it sure as hell looks it. And I keep forgetting that we're at Mount Bruce. This micro scale, we can get good hints of it by considering the synoptic situation. The best information really comes from standing on the hill and feeling what the air is doing, kiting along. It's possible to get things like buoyancy to shear ratios. I think Dr. Jack again publishes those, doesn't he?
I'm not sure. I'm sure they are on SkySite. No, there is a buoyancy shear ratio.
There's a map on the RAS website.
Yeah. I think a lot of people use that and don't understand fully what it's showing. There's no good information to give us any clues as to what things are likely to be on the micro scale, apart from us being on the hill and making an assessment. Unless things are really bad. So, forecasts, really for me, what I'm looking at, if we're all trooping off up Mount Bruce, what's the synoptic situation? How's the boundary layer looking? What's it going to do to the four horsemen? Let's say we plan to go up Mount Bruce tomorrow, not that we are. So, in our imaginary situation, the synoptic pressure gradient is light. The forecast winds are light. We're not too worried about the direction that the forecast is saying, because the wind is coming from southwest or southeast. We've got a heck of a lot of mountains that wind is going to be going over, and no forecast model is good enough when the wind is that light to be accurate enough to be worth paying attention to. If, say, windy WinMet service, well, windy tends to give, per kilometre an hour. Synoptics, if it's in the single digits, I'd ignore it.
And just call it a light day.
Yep, yep,
Yeah.
yep. I've met
You're
services
finding
saying a
what's
light
going on
day.
here up there.
Yeah,
Yeah.
yeah.
When you're talking about wind shear, when you say shear there, are you talking about the southeast and the southwest doing this?
If those wind strengths were accurate, then
Could be this sort of thing happening?
there's not going to be anything of any concern anywhere. So shear,
Right.
we've got enough information in this to say that shear from wind is not going to be an issue. So the next thing is there shear on the edge of sounders? And we've looked into the boundary layer. We know the time of year. We can pick a time of day to some extent. We're confident enough that the shear is going to be manageable.
Just to be clear, that tetragram wasn't for this forecast.
Correct, yes, absolutely, yes. Nobody's going anywhere with that other tetragram. I've pulled up a bunch of stuff at random. Yes, I'm making this up. There's no cloud forecast, and we would see that on the SQT, the tetragram, if we were looking. So this is the key thing. The launch face is north. Mount Bruce, you've got a whole lot of Waimak ahead of you. The sun can shine on it, and I would be confident with a forecast like that, on a bright sunny day, your chances of getting an upslope wind to launch into are really good. So whatever the direction when it's light, I would think on Mount Bruce, a reasonable time of day, any wind generated in the boundary layer from heat, making stuff rise up the mountain, is going to overpower a light synoptic wind.
So Brian, say you're at 2,000 metres and that forecast is say 15, 20 k's, would you call that enough to start to form wind shear?
Yes. Yeah. So I'll come back to that, but it's a good question. For me, if I've got my wing on takeoff, and I'm thinking, look, if this was at Taylor's I could soar, I'm starting to think pretty carefully about what's in front of me and where I'm not going to go.
Right.
And that's the reference point that I use. If I was in this wind at Taylor's, would it be soarable? If the answer is yes, it's right. Need to have pause and have a think. Is this safe? What's upwind? What could be making shear that comes and gets me? I don't want to be lee side of anything in that strength. What's going on in the valleys? It's not necessarily unflyable, but in some situations it will be. Somewhere like Mount Bruce, Bruce can get messy when the wind picks up. If it's coming straight up the face at 15, it faces north, there's probably a fair bit going on in the air. So, here we are, we're walking up Mount Bruce. The observant among you will notice that Linda's walking up the wrong hill. It's probably a bit like finding where you're supposed to be tonight. So we're walking up Mount Bruce, and before we leave home, we're looking out the window. On the drive up, we're looking out the window. We haven't quite forgotten the forecasts. We'll still be checking those, but the forecasts are starting to get overruled by what we see outside. Observation is becoming more important, forecasts less so. The other Top Gun quote. Forecasts now, when we're on the hill, we're walking up the hill, they might tell us something that we can't see, but that's their value now. We're in a better position to judge than any forecaster is, and we can see what models can't. It's also true that models might know something that we don't. So we're walking up Mount Bruce. If the forecast said, hey, there's a southerly pushing through up the east coast, it's going to reach in and maybe tickle the edge of the Craigieburns, we want to know that. But otherwise, what we observe just overrides anything that we see in a forecast. We've got the real thing. The forecast is a model. This, when I walk up Mount Bruce, is really important to me. This is a real personal thing for me. I have a couple of stories. How are we doing for time? That or not?
25 past.
Okay. Couple of stories. One is from base jumping. Two of us got to an exit point and I was just having a bad day. I couldn't get myself together, looking over the edge and going, well, I've got the jitters. Going back, checking the gear, going over, having another look. Conditions are fine, that's not the problem. But for some reason, I just could not get my head in the game. The guy that I was with, CJ, bless his cotton socks, he could see that I was out of sorts, and he came up and said, you know what, I think we should walk down. And I was saying, no, look, I just, I'm okay, I just need to sort myself out. And he said, no, we're not doing it. And I really I want a weather wingman like that. Two more quick examples. When I started flying at Wanaka, a group of us started walking up a hill on a very unpromising day, nor'west day. We got to a point where we were in howling wind and we're basically just going for a walk, but taking our wings is a bit of an excuse to be social. We got to this point where flying was obviously out of the question, and we just sat down on the grass to have a wee chat. And a couple of us were looking up the hill and we could see what looked like a road cone higher up on a grassy hill. There's no track up there. What's a road cone doing up there? So a couple of us walked up, another 100 metres up the hill. We got up there, bloody hell, it is a road cone. What keen person brought this up here? And looked down and I could see my mate 100 metres below me pulling his wing out and was obviously getting ready to fly. At the height that we were in, 100 metres higher, the wind would have been well over 50 kilometres an hour, no question. It was just unflyable nor'west, gusty, horrid. So I charged back down the hill and said to this guy, look, no, not on. Where he was, the wind had dropped a little, it would still have been over 30. Horribly gusty, messy, crossed. And this guy basically said, look, ground suck, go away, I'm flying. And I'm thinking, holy cow, what's going to happen here? He pulled his wing up, lifted, got dragged, hurt his back, and then said, I need you guys to help me launch. And I felt like I was in a very bad situation. If he could get off the hill cleanly, he was probably going to be flushed down into the valley and land, but it was not a good thing to be doing. If I didn't help him, he was going to try and launch anyway. And in the end, I helped him launch, he flew down, and I thought, I never want to be in this position ever again. The people that I fly with, I want them to make good decisions around weather. The part B to that last story was a couple of years ago, I think. Another not very promising looking day. I went up Lewis Peak behind Wanaka, took the single skin up, it's really just going for a bit of exercise. got halfway up and went, oh, I could probably fly from here. I don't want to be any higher, but here is okay. And got the wing out, took off, and I was just having a ball. Just climb up 100 metres, then that's it, it's getting too messy. Fly forwards, drop down, pick up something else and climb back up. Fly forwards, drop down, and I was just doing little loops around Roy's Peak and having a great time. And I saw somebody pull their wing out at the grave, 300 metres below, and I thought, oh gosh, I've got to go down and see who this is, and flew down. Same guy that launched in conditions that I thought he should, and on this occasion he took off, just flew straight out from the hill and landed. And I thought, oh, I'll go down and be sociable. I landed next to this guy and he came across and gave me a complete bollocking. And he was saying that air was rough, it was strong. He flew straight out from the hill because he was hating it. And there was me in a single skin with no reserve, no back protection. What the hell did I think I was doing? And yeah, but if I don't take that on board, I'm a complete idiot. So it made me have a real hard think about what I was doing and the parameters that I was flying in. He was being a good mate that day. And the other day I thought he was being a complete idiot. So, you know, I thank him for telling me that I was being a plonker. So, the weather, the people that I'm doing a weather assessment with, we don't have to come to exactly the same conclusions. We might decide that it's okay for the more experienced pilots, but the less experienced pilots perhaps not. But I do want everyone to be in agreement. For me, that's really important. And I think the other thing is, particularly walking up a hill, somebody will notice, oh gosh, there's a bunch of dandelion seeds floating past in this direction, but I've been feeling it on the back of my neck. Somebody notices something, I don't, somebody else doesn't. The person who notices it could be the least experienced person in the group. I want their input. I want to know what they have felt. Observation, anyone can do. They don't have to be a pilot. This for me is also important. There's a real temptation to go up there thinking, is it flyable? What can I see that supports it being flyable? And I want to make a real effort to go, no, this, I'm having an observe phase. All I'm doing now is gathering information. The next thing is, what does this information mean? And the next thing is, what is the decision based on that information? While we're observing, the forecast means absolutely nothing. We're not trying to correlate what we see with the forecast. We're trying to make a decision based on the forecast. So we're back to the four horsemen. When we're observing, we're only really interested in wind, convection, shear, clouds. I can't think of any other factor that's of interest to me. So all of this is probably pretty obvious. We're up on Mount Bruce, we're looking around. It starts with a real, what's over the horizon? What can we see from clouds that's poking up over the horizon? What's happening right on the horizon itself? Come overhead. Are there any clouds overhead? What are their implications? Bit of cirrus moving in from the southwest. That could shade things out and shut down the thermals. That could mean that the southwest becomes more apparent because we don't have the convection up the hill to override it. we might go, okay, over here at the moment, the grass is really rustling with the wind, but 100 metres away it's not. What does this mean? We've walked up a hill. We know what it was doing at the bottom of the hill when we left. How has it changed as we're walking up the hill? Every single piece of information is worth something. You might discard it later, but you're keeping it in mind to try and form a big cohesive picture of what's going on, where it's happening, and how things will change over time. Wind is probably the thing we tend to focus on. A big thing for me is wind gets mixed up with thermals coming up the hill. Trying to separate them and trying to figure out how steady the wind itself is. Does it build up and then decay in regular cycles? It's quite common for it to do that in cycles of about 5 minutes or so. Try and differentiate that from the thermal that's ripping up the hill. What else? Valley winds. You leave the car at the bottom of the hill in the morning, start walking up the hill. It's calm when you left the car. If a bit of convection is starting up, what about valley winds? Excuse me. If the wind is picking up, are there bits of the sky that we want to avoid? And that's usually lee side. Convection, you can get a pretty good handle on what it's going to be like when you're standing on the hill. You can tell if the thermal is really ripping up, if it's sharp-edged, if there's nothing, then bang, there it is, and it ends with a bit of a thud. It tends to,
So when you say sharp edges, you're talking about the intensity?
yes. Yeah, so you're standing there, and say you've got the tussocks of Mount Bruce beneath you. You can see the tussock start to wave, and here it comes, here it comes, here it comes, and then poof, it's there. The tussocks are swirling all around you, and possibly again 50 metres away, there's nothing. You've got a sharp edge. On the other hand, it might just build up, build up, build up, build up. There you go. You pull your wing up into it, and sometimes it's just a battle trying to keep the wing up. Other times you pull it up and you go, oh yes, I've got this. Usually in the thermal, you don't stand there kiting your wing for long, but you still get a feel, particularly for that leading edge of the thermal coming through, how sharp it is.
So there'd be a bigger lapse rate? Not necessarily.
Not necessarily. Typically a high pressure day, going back to the synoptics, that high pressure day will have the sharp edges. Generally, after a front has gone through, you tend to get more of the thermals that just build up, build up, build up. This is nice, and then it decays softly. There's more of a tendency in the high pressure days for bang, there's the thermal, whoa, and then it drops. And what you feel on the ground is a fair reflection, the best you can do. It's indicative of what you'll feel in the air.
So when you say high pressure days, that they tend to be more aggressive.
Yes.
Is this because of the heating effect? Is this because it's summertime and
it's because
starting to become more powerful?
Sharp edges because the high pressure days are really stable. That thermal doesn't want to climb until it's got an awful lot of heat in it.
Oh, I see what you're saying.
That heat has to overcome that stable air. So on the tephogram, for those who know how to read it, the temperature trace on a high pressure day tends to have a big kink in the bottom of it.
Is that a feel or is only
Right.
those thermals also really have to climb because they're incredibly narrow already?
Yes.
rather than they already are.
Yes, exactly. Yes. Yeah. Yeah, so as a rule, the post-frontal days are a whole lot nicer than the high-pressure days.
I think at Taylor's, that's what we call them, bullet thermals.
Yes. Yep. And clouds again, this is a whole other subject. You know, this is something again you could spend a week on. Cirrus doesn't usually threaten us unless it's changing fast. The high, wispy stuff, it can shut down thermals. It can mean that there's a change coming, but it's not a threat in itself. Stratus, layer cloud, tends to mean you're probably not going to be thermaling. Maybe as it starts to break up. Cumulus, obviously the one we want. Cumulus clouds are full of information. How tall they're growing, how fast they're growing vertically, how wide they are, how dark the bases are, concave bases. All those things you can look at a Q, whether it's building or decaying. They're information rich, and learning how to interpret those is a really good thing. And again, any cloud that's rolling over a range is probably indicative of wind. And a common place where you would see that, you're probably not going to see it at Bruce, Craigieburns, flying on the Craigieburns, and an easterly is pushing through over the plains up to the foothills. You often see that as a band of cloud over the hills.
I've not heard of a concave base on a cumulus before. What would that mean?
Okay, the air is rising so fast in the middle of the cumulus that although, the condensation wants to happen here, but there's so much inertia that it's happening higher up. So a concave base is indicative of good lift. And the other thing that's probably worth mentioning, sorry, this is getting really, really long. The other thing that's worth mentioning is in those situations, what happens when moisture condenses? It releases heat, yes. So the lapse rate improves. So you get close to the cloud and suddenly you're going up and up and up. Yeah, sorry, look, I better speed up a bit.
Hello. This is how we're doing all this.
Yeah, because we're anticipating changes. So the next thing is, look, do we want to add a margin? Is there something happening that could trip us up? And that might mean, okay, there's a change coming, there's a wind change coming, we've got to be on the ground by a certain time. It might mean that certain parts of the sky may go. More than likely it means we've got to land before too long. Right. Look, I'll whip through these. An easy way of thinking about things is each of these things in good order, or do they need care, or is it a no-go? And a traffic light system is just something I came up with. So, look, I'll scurry through these because this is getting a bit long. So, if we've got an idea of the day, we can say, okay, it's okay to fly, but we want to be a bit careful because we're starting to see some of the cumulus over in this part of the sky are starting to look really tall. Things are getting a bit boisterous. The day might be moving towards overdevelopment. It might be okay to fly, but go in this direction and be on the ground in an hour. And the other thing, of course, is the opportunities. Hey, look, it's happening. Let's go. So, Plan the flight and fly the plane. That's where I landed from Mount Bruce. Now, there's one thing I want to mention here. I'll go through this fairly quickly. So, we've got green lights for wind, shear, convection, clouds. So, this is all good. Do whatever you like. The next level up, okay, we've got one or two things that we need to keep an eye on. It might be the wind is picking up, it might be things are getting a bit bouncy, but it's still good to go. And this for me is my favourite conditions. This is where you can make what John calls fishbowl flying. You can find an area, cruise around it, have a good time, and you need a degree of awareness, but it's not overly threatening. This is where the big cross countries are done. And only for the specials. So those Mary Poppins days, those days where thermal flying is possible, but it's not really a big cross-country day. Great days, but I think they have hurt a lot of people. And I think this is why you get that large-scale subsidence that we were talking about. It stuffs up the lapse rates, makes things stable, but it's clear. You get a lot of heating from the sun. Nothing happens until the ground is cooking and it's made a really hot thermal bubble that is pretty reluctant to rise at this stage. So you tuck in close. You're right next to the hill when, bang, the bullet comes. I think, I don't know for sure, but I think this has been a lot of people. And this is something that concerns me in the conditions that I like the best.
So you're saying that on a day you were going out there saying, you're looking for those thermals, you're waiting for them to sort of happen, you think, oh yes, just about now, so to speak, and because it's not quite out there, you're sort of hugging the hill, trying to find them. And then you're saying because of the conditions of the air, etc., it's going to be quite a vicious bloody thermal because of the actual air condition, the aerology of the whole place.
Yes.
Yeah, gotcha. Oh.
Yeah.
That's right.
So the response to that is just stop and wait. Let the first few cycles go through. Just observe, be patient. Sometimes, quite often, the end of the day is better than the beginning of the day if you're looking for more mellow conditions, because the day has started to mix out a bit. So what does this guy mean?
It's going to get
Yeah. Take care. That's pretty much red light. That's getting Keith Richards. Yeah, that's what I was saying before. If I'm on launch and it feels like this is horrible at Taylor's, it's look pretty carefully. So, that's planning for me. And in the air, it's this big iterative process. Assess, make a go condition or no-go assessment of the four horsemen. Make a mental model of what the rest of the flight or the next phase of the flight is. Be alert to changes. And then go back to stage one. It's doing that constantly. I think we'll skip that. If there's a better system, if I've missed something, I would love to know. Yeah. Basically, I think there's a wee trap with apps like SkySight in that we don't necessarily know the big picture. We can miss something by just looking at the app. That perhaps a look at the synoptics, or looking deeper into the boundary layer, might give a hint of. So, yeah, I don't have the answers. This is just what I've come up with.
Another Bryan.
Indeed. If you don't know, I always ask Bryan. We're just about done. What's making that cloud?
Would that be a valley situation?
Somebody said it.
Convergence.
Yep. Yep. So we're looking up the Hakateri. This is Mount Guy. Mount Sybil, Two Thumb Range, Darshak, Main Divide. You can see a bit of cloud over the Main Divide. Other direction, northwest. Yeah, so we've got a southeast sea breeze hitting a northwest, making convergence. Lake Tekapo.
Sea breeze coming in?
Yep. Yep. Easterly starting to dump over the hills here. But we've got cloud here, the higher base than this. There'll be convergence here again. Big dark bases through here. That'll be roaring. Strong convection. But yeah, again, sea breeze moving westerly. That's taken from the deck in Kashmir.
So the southerly front, that's a convergence, but
Yep, northeast, southerly meeting, running right across the plains. Famous incident back in the early 80s where some people who I've never heard of before caught one of these in hang gliders and flew across Christchurch International Airport and shut the airport. I'll rattle through this. This is another day that I got a bit wrong. This is French Ridge, West Matuki. Three of us here, we took off, we flew out from here across to the far side of the valley, going up the whole way across the valley. Turned, went right, and flew a circle, how big would it be? I'd be guessing something like 15 k's, and never had to turn the whole time. The whole upper valley was lifting. What's the wind direction here?
east.
Left to right or right to left?
Oh, I see what you're saying.
Left to right.
I'd say left to
The
right.
clouds are moving right.
Yeah. I have. Yeah. Wind direction there.
Say that again.
The leaning to
Wind
the right
direction
again.
here.
Right to that? Oh, that's east of Summits.
Well, Cirrus could be coming
That's looking down,
across,
yeah.
couldn't they? And
It's
the
right
lower
to
stuff
left.
is
Right
right.
to left, right down,
East
down.
to me.
Okay.
So that's western.
Because the Cirrus here is probably at about 40,000 feet. We can ignore that. This cumulus here is telling us left to right.
It's down right.
Left to right, yeah.
Yeah.
What are you looking at to tell that?
Can you explain?
Sure. The cloud is trying to lift up, and it's been blown over. So it would rise vertically here in no wind, but it's been blown over by the wind.
So you were looking at that when you took off,
Yeah.
and what was your assessment?
Fly.
The fly?
I thought
Was
that
it light enough?
it was light enough. The cycles coming through were pretty reasonable, but I thought the middle of the valley would be sink, and it wasn't. It was lift the whole way across.
Why would you think it was sink?
Because what goes up must go down. I would have expected that convection on the sunny side of the valley, this is east facing, I would expect that air is being pulled up. Where it gets to the top like that, it's got to decay, it's got to pull air in from somewhere, and it's going to be from the other side of the valley, middle of the valley.
Right.
And I got it wrong.
So what was causing, was the valley wind or synoptic wind pushing up the valley and the whole, just pushing the entire head of the valley up? Or?
Pretty much, I think there was enough convection in the head of the valley to set up a kind of a sea breeze-like cycle. Certainly going left and down the valley, we went across in this direction. The other two guys at the end of the flight were flying back out, and they got absolutely drilled in sync. So the upper valley was lifting, lower valley was hefty sink.
With Liverpool, like Bath.
Sorry?
Bath, like Liverpool. That was,
Yes.
Yeah.
Yes. Yep, so we went straight across to Liverpool, and we were higher than Liverpool when we got there. So we're pretty much done. For some of these sites, I think there's no way you're going to get a briefing that's not on the hill whatsoever. Right, just a few to go. The northwest, because this keeps coming up. This is the kind of classic situation. The surface winds, the northwest, are coming across the Tasman. They feel the Southern Alps. Well, they're still a long way out at sea. Air really backs up here. Air is stable. It does not want to climb even the measly height of the Southern Alps. It would rather go for a detour of hundreds of kilometres rather than climb over two. So this is really common. The wind howls through Cook Strait. It tucks down the east coast here as a northeasterly, even though the surface winds on the west coast are northwest. Really, really, really common. And a lot of the time we fly at Taylor's, this is what we're in. Right, northwest comes in, hits the Alps at low levels, goes north and south along the Alps, through. At high levels, comes over the top, really rolls down the lee side of the Alps, hits the ground here and is forced to slow down. This is a hydraulic jump. It jumps up, it overshoots where it was here. It overshoots its natural buoyancy because it's going too fast and it has inertia. It goes, whoops, I've gone too far for the amount of buoyancy that I have, crashes down and does that. Here's your rotor, and again it's that action of rolling. And here's the Port Hills. This can touch the top of the Port Hills. Often we fly at Taylor's when it's like this because we're in that surface easterly. In that situation, we are trying to be really careful and look at what's going on at Allendale. Allendale is higher. If the northwest touches down at Allendale, it's get out fast. Often you can see bits of dust being kicked up in the lower plains, and again, that's red light stuff. That's Keith Richards.
Sometimes with a layer of cloud in the northwest, the underside of it is scalloped. Is that
Yes.
the wave?
Yes. Yes, in fact, we'll have some photos of it. Edwin, have you flown in wave? Yeah. You get beautiful lenticular clouds.
Oh, yeah, absolutely.
Yeah.
He's flying on a sail plane on a ground.
Can you just go back to the hydraulic jump? The hydraulic jump, can you just elaborate, please?
Okay, the hydraulic jump. The place where you see this is often dam spillways, where the water goes over a spillway, hits the ground at the bottom and makes a huge foam pile. It's exactly the same here. It hits hits a spot where it has to slow down and it bunches up and builds up.
Oh,
It
So-
doesn't always happen in
yeah.
Norway.
So when you're saying that, you're saying look at Allendale, the whole fire at Allendale, and you'd be looking at the northwester coming through that way. Why would I be looking at that? Would I be looking at that thinking, is it a go or is it a no-go?
If you've got a northwest looking sky
Yeah.
and you're flying at Taylor's, then the hazard is that northwest drops down and hits you at Taylor's. And to avoid that, before it does that, it's got to go through Allendale.
Right, so you get a prediction into Allendale before it actually would happen. So to speak.
Look at the weather station at Allendale,
Yeah, the weather station.
Yeah.
when they take off,
Look,
Yeah, yeah.
or you just don't fly on days like that.
hopefully, because the warning you get may be really brief. This has killed people. Getting stuck in the northwest has killed people.
Yeah, but I was just sort of thinking about that northeast that comes through Cook Strait and it comes around.
Yep.
We'd be flying in that. Like
Yep.
you said, it's quite normal conditions.
That's common.
So what I'm asking is, if there is a northwest tendency obviously happening, while that's happening, while you're thinking, oh, it might be good to fly at Taylor's, direction's great. So you'd be looking at Allendale to see what strength the northwest is there to tell you that, no, it's a little bit too close to be flying at Taylor's in the northeast. Is that what I'm
Yes.
reading here?
Yes. Look, if it's a northwest looking sky, this is very classic. You've got clouds here that you only see in the northwest. If you're looking across the Canterbury Plains and seeing that, you need to be really careful before you go flying anywhere.
So we're looking at clouds that are layered, got layered clouds and are dark,
Lenticular clouds.
lenticular.
This is really typical. Look, can we name these clouds here? Where's the roll cloud?
Down, stop, up, yeah, there.
Yep. Okay, so roll cloud rolls over the top of the hills. We've got really obvious lenticulars. We've got rotor cloud. You've got a sort of combined wave rotor cloud here. You've got something that's trying half-heartedly to be a lenticular. They're not the classic beautiful lenticulars that we sometimes get. If you see a sky that's got signs of northwest in it, then you want to be sure before you go flying. And if you are going flying, it's probably going to be at Taylor's, and Allendale is the thing you're going to be checking. You're going to be looking for any dust coming up off the plains. You're going to be noticing if the air suddenly feels drier, warmer, gustier, shittier. You can often, but not always, tell how it's on its way.
While you're talking about this, what I'll talk about is the Taylor's mistake is the indicators that the northwest is actually starting to push into Taylor's mistake if we're flying there in the northeast. Now, first of all, the northeast will start to die off. The red soaring you will not be able to red soar anymore at Taylor's mistake. The second condition you look for, if it starts swinging north, that's another good indication that the northwest is trying to push into Taylor's mistake. And the third one is the temperature difference. All of a sudden you'll be at Taylor's and the temperature will start to rise quite an amount quite quickly. So what happens is if that northeasterly is backing off so you can't grid soar anymore, they might drop down to 6, 8 k's, 10 k's. You can't grid soar anyway. Just be aware that northwesterly could be hitting the Canterbury Plains or at Christchurch Airport. Where you can check is where Bryan said at Allendale, or where you can check Met Service, Central City, that's Christchurch Airport. You can also check, I can't remember the number off by hand for the Christchurch Airport. They give a readout from ground level what it's at the landing strips up to 2,000 feet, and I think that's updated about every 10 minutes or something. So that gives you an indicator of what's actually another indicator. So if you're red soaring at Taylor's mistake, and all of a sudden everyone's to stop flying at Taylor's Mistake. That's the first indicator that nor'wester is trying to push in. Sometimes at Taylor's Mistake, the wind will stay around 6 to 10 k's, and it won't actually get any stronger, and the nor'west won't pick up anymore. Quite often I've left Taylor's Mistakes over the years. I've been ridge soaring there. It's been a northwest sky. The northeast has backed off. We'll start to go north. I can't ridge soar anymore. I've landed and I've gone home. And I've got home. There's been quite a strong northwest in the city centre. So all I'm just saying is what Bryan's been saying is there's good indicators at Taylor's Mistake with the northeast that the nor'wester is coming. And believe me, do take that, take note of those conditions are changing, Cliff.
And the ships.
And the ships as well. But they're the three main things. The northeast will back off, you can't ridge soar anymore. It will start to swing north, the temperature will get, it'll start to rise up in temperature. And just be aware that even if it gets to those conditions, be aware that if that nor'west, if you start to stay at Taylor's Mistake and just kite your wing up on top and just those very light winds, just be extremely careful, because if that nor'wester does come in, it will slam in pretty hard. And what can happen there at Taylor's Mistake, when the nor'wester does come in, it rotors over top. It is, a lot of you may have noticed, Taylor's Mistake hill is quite curved. It's not very sharp, it's quite curved. So what can happen if that nor'wester comes in, it will gradually roll over top, then come back up. Now unfortunately, there was about a year ago, there was a serious accident there due to very similar conditions. They were just kiting on the ground. And we think a nor'wester hit, and they thought it was a northeast, strong northeast. It was actually rotated from the northwest, and they got ripped off the ground. So all I'm saying, it's fine to fly at Taylor's Mistake when it's northeast, but just watch out for those conditions when it's changing. Because once it starts to change like that, I've seen it, so when it goes from non-soarable to northwest, it can be like an hour or half an hour. So you just got to keep that in mind. I've been flying that particular site for a year or two now, and I've just managed to read those conditions over those years, what it's doing. I've never ever seen that nor'wester just slamming like that at Taylor's Mistake, if there's already a northeast there. I've always found the northeast always gradually backs off, and then it will start to swing around. So just be aware of that. Because a lot of pilots have asked me over the years, why do we fly at Taylor's Mistake in the northeast, although it's a northwest sky and all that. As Bryan mentioned before, the effect of how it pushes down the coastlines then comes back. So we're actually flying the northwest, although there's a northeast direction. So they're just things to look out for if you do fly at Taylor's Mistake. Although there is a northwest sky, do not fly the Port Hills. Stay well away from Port Hills when it's northwest. I've seen people flying there over the years up at the gondola, and believe me, they've been extremely lucky that nor'wester hasn't hit them, because you've got to remember the nor'wester is a wave wind and it touches down at any time, anywhere. So you can be driving along the road, perfect example, you can be driving along the road, 10 minutes up the road it could be dead calm, or it could be dead calm where you are. 10 minutes up the road it could be 100k winds. Because the nor'wester is touched down. So all I'm going to really say is just have so much respect for this nor'wester. Anyhow, is there any questions, just ask any time. But anyhow, let's keep off.
Yeah, thanks, Liz. Yeah. Very famous photo of the Sierra wave. This guy was climbing at 6,000 feet a minute, nearly 2,000 metres per minute, with his engines off in a P-38 in wave. And the New Zealand nor'west wave is no different.
600 feet a second. That's cool.
Yeah, where's Edwin? Yeah. Tyree Pet is, this is a lenticular often forms in this spot. often enough to have its name when it shows up.
Where is that?
Tyree, Dunedin. That's from the deck at home. Now this guy here, this guy really intrigued me. We're, 20 metres above sea level? Something like that. I don't know what height we are above the plains, 18 metres or something. I reckon this is rotor cloud here, and it's incredibly violent. The team of glider pilots that were exploring the wave back in the 50s, 60s,
George Dickinson?
the Sierra wave.
Oh, sure.
Yeah, they were pulling 20 Gs trying to fly straight. So this will rip a paraglider or a reserve apart. I reckon that top was probably at about 300 metres. No other cloud is anywhere threatening looking in the sky apart from this. On the deck at home, it was absolutely flat, dead calm. That rotor stayed there, stayed there, stayed there, stayed there, stayed there, and then bang, it was on the deck at home. And when I took that photo, you could have done a no-wind launch. There was nothing at all. So that's the nor'west. A lot of people are asking if it's safe to fly, and yes, there are certain circumstances where you get a nor'west wind, but it's not a nor'west blowing over the Alps. But I really feel if you have to ask, you shouldn't. And this one intrigued me. The one on the right is incredibly rare. You don't often get a southeasterly that's strong enough to set up a wave on the west coast, but that was Aerology. When we're going skiing in the glaciers. Yeah. So it's the point being is wave is when a strong wind blows over a mountain range. It's not specific to any direction or any particular mountain range. I have 3 stories, I'll make them brief. I took off at Little River, Dean Landreth was there. It was blowing perhaps 5 kilometres an hour of northwest, and Dean said he could see top surface of, this is hang glider, top surface, bottom surface, bottom surface, like this until I landed. Magic Mountain, we deliberately flew into the wave, we connected it into it, flying from Magic Mountain, got to 15,500 feet. Thought, what the hell are we doing here? Went downwind, landed at Omarama Airport. Guy I know was doing the Met briefing for World Gliding Champs, which were being held there at the time. My mate and I were both gibbering wrecks, having survived being at 15,500 feet in Norwest Road. Hang gliders landed, went into the briefing, and Richard was reminding the glider pilots to drop their water ballast at 18,000 feet so that it doesn't freeze. Worlds apart. And Taylor's, on one occasion, I did take off there, dying northeast. You get there, you rig up a hang glider, the wind is dying, you know the nor'west is coming. I got greedy, I thought I'm going to scoot straight to the cliffs, hang a left, land on some of the beach. I got to the cliffs, and as soon as I got there, I dropped beneath cliff top height and squeezed on into the beach at Taylor's. It's no joke. So I think we'll leave that. The worst advice ever comes from Maverick. So, quick recap. All we're trying to do, all I'm trying to do is think about those things, the 4 horsemen. That's it.
Any questions?
Yeah, one question. You know, I asked you about a month ago about winter flying for the northwest. Could you please explain that again, why the northwest doesn't seem to touch down at winter?
Yeah, it can do. The northwest is a real battle for stability. The northwest itself, you've got wind that's come across the Tasman Sea. It's come from somewhere warm. It's a very stable wind, which is why it makes wave. You couple that with an inversion over the plains, and the two don't want to mix. So the northwest will just want to glide across that inversion instead of bouncing down to a lower altitude.
But it could still touch down at winter in the same...
It can do,
manner
it
does
can
the
do
summer?
anything, yes. Yeah.
Okay.
It's from the point of view of someone who's obviously very inexperienced with this, and the way I've been thinking about it with my sort of planning around flying and looking at those sort of northwest forecasts is it's about margin. So if you are inexperienced, you don't want to go out there when your margins are going to be finer, because you've already got other things which are eroding your margins to do with not being experienced. So,
I think for a lot of us who are experienced, we've got other things to live for and don't want to take the risk.
so you want to keep the same margins.
Look, for me, for a lot of these things, it's just not worth it. You know, people are often scrambling to fly on days where really it's hazardous. And for me, I've got other things to do. I've got other things to live for.
Very good. Well, thank you very much, Bryan. It was a very informative talk. There's a lot of information in there. And I think we're all very appreciative of that, of giving us the benefit of your experience and wisdom. And I'm sure people will want to nab you and explore some of those topics further. But
That